Today we are going to discuss about abstract data type. So in data structure, abstract data type is very important term. So by the definition, ADT is the way we look at a data structure, focusing what it does and ignoring how it does the job. So generally it will look the simple type, just what will be done and it know how it does the job. And there will be another point, ADT is a set of elements together with a set of well-defined operations. So ADT not only focus on the elements and it also focus on the operation specifically, not in the detailed manner. And it is one of the extension of modularity design. So modularity, which is nothing but the division of operation. The operation will be divided into various modularity. And ADT used to understand the design of data structure. So it also represents how the data structure has been designed. So we can divide the abstract data type into two terms. One is abstract, another one is data type. So abstract, which is nothing but means not considering the detailed specification or implementation. It just gives the simple specification, not in the detailed manner. And data type is a variable, is the set of values that the variable can take. So there is the basic definition for the data type. Okay, so this is the basic thing about abstract data type. And abstract data type, so it may have some of the advantages. So ADT make the simple modification of the program. So if the program is in the very big format and ADT divided into the various modules, so that the program will become very simple. And it also separates the use of DS from the details of its implementation. So it will always give the simple specification, not in the detailed specification. So these are the major advantages of the data structures. Okay, abstract data type. And next we are going to discuss about the list ADT. So list ADT, which is nothing but a list, which is nothing but is the ordered set of elements, and each and every list contains the first element and last element, and also we can count how many elements are present in the list. Okay, so by the definition, list is an ordered set of elements, and collection of elements is also called as the list. And this is the example for the list. So in this example, A1, A2, A3 until AN. Here A1 is the first element of the list and AN is the last element of the list, and here n represents the size of the list. So the n will be the 10, means the list size will be 10. If the n value is 7, means the size of the list will be 7. Okay, and one more important point is list also comes under the linear data structures. Okay, and next, what are the operations we can perform on the list? Generally we can perform nearly 7 operations on the list. So the operation having also some of the operation having the argument, one argument, some of the operation having 2 arguments, and some of the operation do not want any arguments. So it always depends on the what type of operation you are going to perform on the list. And initially we will start with the insert. If you want to insert an element into the list, you need 2 arguments. One is the which element you are going to insert and which position you are going to insert. So that is, you need 2 arguments. So x represents the element you are going to insert into the list, and 6 represents the position. Okay, and deletion operation. So deletion operation, which is nothing but which element you are going to delete from the list. So it need only one argument, which is x. So the element x will be deleted. And find, if you want to find the element in the list, you can perform the find. And find also known as search operation. It will return the position of the x. So if the x is present in the list, and it will represent the position of that element. Okay, and previous, so this operation return the position of the predecessor. So predecessor, which is nothing but previous element, and next return the position of the successor, which means the next element. I means it will return the I+1, and print elements, it will display the list content, and finally makes empty, it will delete or it will make the free space. So these are the operations we can perform on the list. And the list can be implemented in 3 ways. One is array implementation, another one is linked list implementation, another one is course. So the implementation, which is nothing but how the memory going to represent. So how the data will be occupied in the memory location. That is called as implementation of the list. In array implementation, the elements will be occupied in the one by one manner. And when you come to linked list implementation, the data will be represented by the data elements will be linked by using the address. Okay, and cursor implementation. So these are the three types of implementation of the list. Okay, and so again we are going to start with array implementation. So array implementation, which is the very basic type of implementation. Already you know about array, very familiar about array. So again we will start with a definition. An array is a collection of similar data elements, homogeneous data elements, and the data elements can have the same data type. That is another important term. So if you want to store the integer, it will store integer data type. If you want to store the float, then it will store the float data elements only. Okay, and the elements of the array are stored in the consecutive memory location. That is very very important. So the elements will be stored one by one, or in the consecutive, or in the linear format, and are referenced by the index. So here the index, which is nothing but it may be known as the subscript or array address or index. Okay, if you want to access the element, you have to specify the index value or subscript value. And the subscript is an ordinal number which is used to identify an element of the array. So in this example here we have nearly marks 1 to marks 20. So 20 elements are stored. So here marks 1, marks 5, marks 9 represent the index or the subscript of the array. So these are the important term about the array. And declaration. So this is the general arrangement of the memory arrangement of the array. And if you want to use the declaring, if you want to use the array in your program, so you have to declare. So this is the general type. The declaring of an array means specifying the following. So it contains the data type, what kind of data it can store, maybe integer, character, or float, or double. Okay, and then you have to specify the array name, which is used to identify the array. And third one is size of the the maximum number of values that the array can hold. That is the size of the array. The general syntax is the type and name of the array, and you have to specify the size. And follow the example is I'm going to declare the integer data type array, and the array name is marks, and the size is 10. Okay, so if you declare the array, the diagram depicts the memory location, first element, second element, third element, until you can store 10 integer element, and marks 0 represent the index or subscript. Okay, that is the memory representation of an array of 10 elements. And next one is operations on array. So what are the operations you can perform on array? So generally we can perform nearly 6 operations on a array. One is traversing an array, inserting an element in an array, searching an element in an array, deleting, merging, at last one is sorting. Okay, so these are the major operations we can perform on an array. So again we will start with the traversing operation. So traversing, which is nothing but visiting each and every element in an array only one, then such an operation is called as traversing. So traversing, and array is a linear data structure, so that it can be arranged in the sequential manner. So traversing its elements will be very simple and straightforward approach. Okay, that's first point. And this is the algorithm depicts the traversing operation. So initially you have to assign the lower bound value to the variable I, and the while loop, which is used to perform the traversing operation from first element to last element. And the while loop, you have to check whether the I is less than or upper bound. Upper bound depicts the size of the array. Once if the I value greater than upper bound, the while loop will be fit, and the algorithm will get finished. Okay, and in that apply process you can apply any one of the process. Even if you want to count the element, and you can add the data item, whatever maybe you want, you can apply your process, and whenever you complete one loop you have to increment the index value one by one. That's why I equal to I plus 1. So this is very simple operation, traversing operation. Okay, so this is for the algorithm for traversal. And next one is, if you want to insert an element in the array, then which is called as inserting an element in the array. If an element has to be inserted, that can be possible only at the end of the existing array. That is very, very important. And end the task of the insertion, very simple. And one more thing is the insertion quite simple, and if you want to insert the array, that can be possible only at the end of the array. Okay, for example, if you come and consider the array in the size of 10, so already you filled 6 element, and if you want to try to insert one more element in the array, the insertion only possible after 6, which means the insertion will take position at the 7th place only. Okay, so it is also quite a simple operation, and this is the algorithm depicts the insertion. So you have to increment the upper bound value by 1, so upper bound equal to upper bound plus 1, and set a of upper bound equal to value. So which value you want to insert, then you can assign the value into a of upper bound. This is upper bound, which is a of upper bound, which is nothing but a subscript value, and finally you can quit the algorithm. This is the simple algorithm for the insertion. And there will be one more case is also possible when you are going to insert an element in the array, that is called as middle of the array. Okay, so this algorithm insert will be declared as insertion. So A will be represent the array name, and N is the size of the array, and position, in which position you are going to perform the insertion, and finally value. Okay, so these are the things about these are the arguments you need when you are going to perform the insertion at the middle of the array. Okay, and this is also a simple algorithm. So here the while loop will be for processing until I greater than or equal to position. Okay, once if the condition getting false, you have to quit the loop. Okay, this is the format. And when you, for example, this diagram depicts the example. So in this example we have 6 elements, 45, 23, 34, 12, 56 and 20. So here I am going to insert the data and the 6th position. 6th position I am going to insert the in this value I am going to insert the value 100 after 3rd position, and 6 represent the total LM. Okay, so 3rd means you have to insert the element of 45, 23, 34. So after 34 represent the element 3rd. After 34 you can insert the value 100. Okay, that is the example for the insertion operation. So today class we start with abstract data type, and we discuss about the array and operations of array, and today we completed insertion of the new element in the array, and from tomorrow we will discuss about the addition operation. Thank you.